Hello, gentlemen. We have already seen the transformation of a 2D figure, and the figures got transformed from rectangle to the cuboid shape. And what if we look at the other type of the transformations? Where the 3D shapes will be of a little bit different type. That means now the 3D shape is the cone or even the hemisphere or a sphere. Let's talk about the formation of the cone. Cross-section of the cone passing through its midpoint is the isosceles triangle, and one half of the isosceles triangle is a right angle triangle. When the right angle triangle is rotated about one revolution of 360 degrees, it would have already formed the cone. Now, in the case of the formation of a cuboid from a simple rectangle, the volume of the cube was found by the multiplication of area of the rectangle and the distance through which it was dragged. And now, as the triangle is rotating, the path covered by the triangle is not a straight line, but a perimeter of a circle. And now the question comes, what would be the radius of the circle for which the perimeter is to be considered? The answer is simple. Now let's go over to the board and try to find out how it can be done. As per the cross section of the cone through its mid-axis, it would be just like the isosceles triangle, and one half of the isosceles triangle is a right triangle. When we revolve that right triangle about its perpendicular, the volumes that it would be sweeping around, it will make a complete cone when it revolves around by one revolution, that is by 360 degrees. We'll see how it happens. From the first position, let's go on rotating the right triangle by some angle in the anti-clockwise direction. And according to that, we try to find out the curvilinear distance the right angle triangle has to travel to form the cone. So let's first take the first position, which is shown here, and the next would be this one, and next. So this way we saw that the right angle triangle is going on rotating, thus forming the cone. And now the question comes, how we shall find out the effective distance along the curve, which would be the perimeter of a circle, which the right angle triangle has to cover. The perimeter would be of such a circle through which the area of the right angle triangle is to be concentrated. That means the question is about center of area of the right angle triangle. Now we know that center of area of the right angle triangle lies along a axis 1/3 from any of the sides. So if we consider the perpendicular of the right angle triangle, the center of area of the triangle will be lying along an axis, this axis. The distance between this line and this line will be 1/3 of the radius. And if this is the height, the center of the right angle triangle would be lying somewhere here. So it will also be 1/3 of the height. So in this way, you can see that curvilinear distance the right angle triangle has to cover is the perimeter of such a circle, the radius of which is 1/3 of the radius of the cone. So the circle is this one, and the perimeter of the circle will be 2 pi into the radius of the circle, that is 1/3 of the r, that is equal to 2 by 3 pi r. Now let's see what would be the volume of the cone. So volume of cone is equal to volume swept by right triangle rotating over 360 degrees. That is equal to area of right triangle into the curvilinear distance. That is equal to the area of the right angle is half the radius of the cone and the height, and the curvilinear distance is 2/3 pi r. And this is same as the formula of the cone by simple mathematics, that is pi r square h by 3. So we can also find out the formula for volume of the hemisphere or even a full sphere by taking the cross section to be revolving around over one revolution. And it is to be noted that when we want to find out the volume of hemisphere, we have to revolve the half of the cross section of the hemisphere, that is the 1/4 of the circle, to be revolving by 360 degrees. And when we want to find out the volume of the full sphere, we have to take the half of the cross section of sphere, that is the semicircle, to rotate around 360 degrees. So that would give us the volume of the sphere. And this is all about the method of finding the volume of the shapes out of the figures having the lower dimension. I hope you have enjoyed this video. Do subscribe to this channel for this kind of interesting topics. Please give it a like and do share this video among your friends so that they can also be benefited out of this. And now let me tell you that you can see that it is very much related to the calculus, where by integration the exponent of the variable increases by 1, and in the differentiation it reduces by 1. And this is exactly the same what we found here. Next videos will be really interesting ones, and one such topic would be to find out the cross section of an irregular shape, just like a piece of stone or a shape of a potato. It seems impossible, but it can be found out easily. We can find out the relationship between the perimeter and the area of the circle at any radius, and the surface area of the sphere at any point. So stay tuned. I will be posting videos based on this. So see you soon in the next video. Till then, take care of yourselves. Bye bye.